Hi guys, in today's video I'm going to be starting with the AP Calculus BC syllabus. I'm going to be discussing the first topic, which is limits. So a limit is represented as LIM, limit. I'm just going to give an example first so that you guys can understand how it is. So this is how it's written. So this x and hyphen minus 2, that's just x tends to minus 2 and this is our function. So now what we do is when they ask us to find the value of this, you just substitute minus 2 into this function. So it's similar to functions, but then it changes a bit as we move. So you minus 2 whole square is 4 plus 8 plus 1, which is equal to 13. So 13 is our answer. So now that we found the value, sometimes, however, in limits, you get 0 by 0 or anything divided by 0 as your answer. So then you cannot determine whether it exists or not. It could exist or it could not. It could or could not exist. So what I mean to say is after substituting a value into the function, you could get 0 by 0, but you shouldn't like conclude that it doesn't exist. You have to do an additional step. Let me give you an example. Limit x tends to minus 2. Limit x tends to minus 2. X square minus 2x minus 8 divided by x plus 2. So now if you want to solve this, if you substitute minus 2 directly, you get 0 by 0. So what you have to do is you can first factorize the numerator. If we factorize it, we get x minus 4 into x plus 2. Second, x minus 4 into x plus 2 divided by x plus 2. So this is after factoring. And I'll just write this 1 second. Limit x tends to minus 2. So now what we can do is we can cancel out these two, right? X plus 2 and x plus 2. So now what we have is limit x tends to minus 2, x minus 4. So now if you substitute minus 2 in this, you get minus 2 minus 4, which is minus 6. So minus 6 is your answer. So thus you cannot conclude if it doesn't exist if it's 0 by 0. You can always try to factor it. There'll be many questions like this. So you might have to factor cubic or quartic equations. It changes and it depends on every question. Now I'm going to be giving another example, but this is a slightly different case. Limit x tends to 2. 2x plus 5 divided by x minus 2. Now, if you substitute 2 in this, you get 9 by 0, which is obviously not defined. So you shouldn't conclude that it doesn't exist. But if you want to factor this, you really can't, right? Because both have only one power of x. The power of x is 1. So what you do is, we take 2 minus and 2 plus. I'll explain what this is. This is not minus 2 or plus 2. This is 2 minus and 2 plus. So for 2 minus, you just substitute a number which is less than 2, but not 2 less. For example, x equals 1.999 or something like that. And then for this, you can do 2.0001. So what we write is limit x tends to 2 minus, and then the equation, not the equation, the function, 2x plus 5 divided by x minus 2. And then on this side, we write limit x tends to 2 plus. Okay. X tends to 2 plus 2x plus 5 divided by x minus 2. Okay. So now we substitute 1.999. Just substitute a number which is much less, which is less than 2, but not too less. So if you substitute 1.999 in this, what do you think you get? So in the denominator, it's 1.999 minus 2, which is a very, very, very small negative number. It's like negative 0.000 something, right? So then what you do is, if you have anything divided by, so we know the numerator is going to be positive, right? So if you have a positive numerator divided by a very, very, very small negative number, then the value will be negative infinity. That's how we write it. Even though it might not be exactly, it'll still be a very, very high number. So we write it as negative infinity. Now, what about this? 2 plus, so say we take 2.001, 2.001. So if you input 2.001 in the denominator, we get a very, very, very small positive number, right? And the numerator stays positive. So what is a positive number divided by a very small number? That would be positive infinity. That's how we just write. So now, so this is positive infinity, right? And this is negative. So when limit, so we know limit extends to 2 minus of this is negative infinity and 2 plus is positive. So when the two limits x tends to 2 plus. So we know that minus infinity and plus infinity are not equal. So when they are not equal, it does not exist. I'm just writing it as D and E, does not exist. So for it to exist, limit x tends to 2 minus should be equal to limit x tends to 2 plus. Now let me give you an example of when it does exist. Limit x tends to 0, 4 by x squared. So if you substitute 0, you get 4 by 0, which does not exist. So now we do 0 minus. So what will happen if you take a number just slightly less than 0? So it will be a negative number. But what happens when you square a negative number? It becomes positive, right? So that's why it's positive infinity, because it's still very small even if you're squaring. So this is positive infinity. So now let's try it for x tends to 0 plus. So say 0.00001. 4 by that square would be a very large number, so we write it as infinity. So now we know that limit x tends to 0 minus is infinity and 0 plus is infinity. Hence, it exists. So therefore, this is a symbol for therefore. Limit x tends to 0, 4 by x squared is equal to 0. So it does exist and it's equal to, sorry, it's equal to infinity. Yeah, I'll just write it again. 1 second. So it's equal to infinity, not 0. Okay, so now I'm going to be moving on to the next question. I'm going to be giving you an example of factoring. What we did before learning this. So limit x tends to 1, x squared minus 2x plus 1 divided by x cubed minus 1. X squared minus 2x plus 1 divided by x cubed minus 1. So I want you to do this as homework and comment your answer for what you get for this. The hint is you have to factor it as it does exist. Okay, that's it for today's video, guys. In today's video, I started with AP Calculus BC syllabus and I discussed a little bit of limits. Thank you.